So in tonight's homework, we are going to be multiplying binomials again. However, they are special products. We are going to be multiplying a binomial square like we have in the first four examples. And then over here we have some differences and sums that we will be multiplying. So let's take a look at the first one. Common mistake. This is the common mistake people will make. They're going to square the x and get x squared, and they're going to square the negative 4 and either get a positive 16, or sometimes they just write minus 16. And that's wrong. Don't get in that habit. Whenever you see a quantity being squared like this, we're going to end up having to write it out as two binomials, and then we're going to multiply those two binomials. And we'll stick with that FOIL method, the first, the outer, the inner, and the last terms. So let's see if we can do this. Eventually, you'll figure out that there's a fast way to do this, or you'll just understand a principle behind binomial squares, and you'll be able to do it quicker. But for right now, let's use that FOIL method, and then we'll figure it out. These are our first terms. Those are x and x, which make x squared. And then the outside terms, the x times by the negative 4, which makes negative 4x. Then we move on to the inside terms, and that's this negative 4 multiplied by this x, and that makes a negative 4x. And the negative 4 times by the negative 4 makes a positive 16. So when we combine these numbers, what we see here is that the outer terms and inner terms are not going to cancel, but they're going to add together, because they'll always be the same sign when we have a binomial squared. So we're going to add those together. That makes a negative 8x, and then we bring everything else down, x squared and the positive 16. So a couple things to remember when we're dealing with binomials that are squared. Our first and last terms will always be positive. So these two are always positive, and the outer and inner will always be the same number and the same sign. So they will always add to make that other value. So that's a key thing that we need to remember. So first and last are always positive, and the outer and inner are always going to be the same, and they'll add together to make another number. So let's see that rule in action again. Let's write this out twice. So we've got a x, or 2x plus 3. We'll write in another 2x plus 3. And so let's see those first, outer, inner, and last terms. Again, as I said before, the first and last are going to both be positive, and the outer and inner terms will be the same sign. So let's go ahead and multiply and see what we get. We'll start with the 2x times by the 2x. So that makes a 4x squared. Notice this will always be a perfect square too, because they're the same numbers being multiplied. Now those are our first terms. Our outside terms are going to be 2x and 3. So positive 6x. Notice the inside terms, they're exactly the same. 3 times 2x makes another 6x. So these are always going to be the same number right here. And then those are the inside terms. The last terms are the 3 and the 3. And that makes 9. See, another positive number. So the first and last terms are always going to be positive. They will always be perfect squares. So 4x squared plus, and then these add together, they make 12x plus 9. So again, something to look at is that those outer and inner terms will always be the same with binomials that are being squared, and the first and last will always be perfect squares and positive. We'll see that same case in this next example, so let's take a look at it. We've got a 2 plus x. So this one's a little different. This is in ascending order. It's going from the constant to the variable. And so that's okay. We'll just continue writing it when we get our answer. Typically we'll see in descending order. This time it'll be in ascending order. So we'll start with our first terms. First terms there are 2 and 2, which make 4. And then we move on to the outside terms. Those are 2 and x that make 2x. And then we move on to the inside terms, and that's x and 2, so it makes a positive 2x. And then those last terms, the x and the x in this case, which make an x squared. So you'll see this is in ascending order, lowest exponent to highest. Well, again, same thing again. First and last are perfect squares, and they're both positive. Outer and inner are the same number, same sign, so they always add together. And so we end up with a 4 plus 4x plus x squared. And there is our answer. So you could write it in ascending order, descending order, either way, as long as it's in one of those two forms. Let's take a look at the next one. This time it's a little different because we have two variables in the problem. So 7a and 2c. And then we'll do it again, 7a plus 2c. So when we go ahead and multiply those first terms, we end up with a 7a times 7a. So our first are going to be 49a squared. Make sure you get that a squared. Sometimes people forget that when they're multiplying the first terms. Those are our first. Let's take a look at the outside terms. It's a 7a and a 2c. So outer terms are going to be 7 times 2 makes 14, and then ac. So the inside terms, if it's a binomial square, these will be the same number, same exact monomial as the outer terms, and that's the case. 2 times 7 makes 14, and we have a and c. Now CA is the same thing as AC, so I write it with the variable that comes first in the alphabet first. And then we move on to our last terms here, 2C and 2C, and so that makes a 4C squared. So just as before, we've seen it again now 4 times. Our first and last are always positive, always perfect squares. 49A squared, and then over here we have a 4C squared. Our outside and inside terms are always the same number, and they're the same sign as well. So they'll add together. So 14 plus 14 makes 28 AC. And then we also have that 4C squared. And there's our answer. So what the book's going to tell you is what you can do when you see a binomial square. You can square the first term, like the 7a, square that because you're multiplying it by itself. That makes 49a squared. You can square the 2c. That'll be, again, 2c and 2c are the last terms. That'll be 4c squared. And then double the product of these two terms, 7a times 2c. So you do it twice, 7a and 2c, 2c, 7a. So if you double this product, 7a times 2c is 14ac. Double it, you get 28ac, and that's the middle term. So that's what they'll talk about on the first part, or the binomial squares. Let's take a look at sums and differences. Sums and differences are just another special product, and they have a certain way of coming up with an answer each time that makes the problem easy. So let's see what happens. So it's already in the form to go ahead and multiply. So we're going to multiply those first and outside terms. 2x and 2x make a 4x squared. So just as we had with the binomial squares, the first term is going to be positive. 2x and 2x, 4x squared. Well, not always. I guess I could have a negative sign here, but it will be a perfect square as long as it's positive. And then those are the first terms. Here are the outside terms. 2x and 5 make a 10x. Well, here's the difference. See, these are opposite signs. So when I move over to my inside terms, notice what's different. Negative 5 and 2x. That makes a negative 10x. So there's the difference right there. The outer terms and inner terms will be the same, but they are going to be opposite in sign. Last terms, negative 5 and positive 5 make a negative 25. So this time, with the outside-inside terms being the same number but opposite in sign, they're going to cancel out. They're going to make 0. So we're just left with that first term and the last term. Notice that the first term and last term are opposite in sign. They're always going to be that, opposite in sign. So 4x squared minus 25. We call this a difference of squares. When we have a perfect square and another perfect square with a minus somewhere, either in front of the 4x squared or in front of the 25. Just one minus sign, so that way you subtract. Well, let's take a look at the next one. This time, same sort of thing. We're multiplying the 3x by the 3x. Those are our first terms. They make 9x squared. Then we move on to the 3x and the negative 2y. Those are our outside terms. They make a negative 6xy. Now notice that when we move on to the inner terms here, we get another 6xy, but it's not negative. It's positive. Positive 6xy. And then the last terms, 2y and negative 2y, make a negative 4y squared. So just as we saw before, when we multiply a difference in a sum, we're going to end up canceling out these outer and inner terms because they're the same number but opposite in sign. And so what we're left with is a difference of squares. 9x squared minus 4y squared. And that is our answer. So you're always going to end up with that. The difference of squares will always have just one negative, so that way we can take a difference. Two negatives would make a positive. That would not be a difference. Well, let's take a look at another one. Here we have 9 and 9. That's going to end up multiplying to make 81. So this time we have it in a ascending order this time. 81, so for the 9 and the 9. And then we multiply the 9 and the x to the third. So those are outside terms. That makes a positive 9x to the third. Well, we move on to the inside terms. So negative x to the third and a positive 9 make a negative 9x to the third. And then the last terms, negative x to the third, positive x to the third, makes a negative x to the sixth. Watch that exponent. You'll see other exponents other than just 1 inside the parentheses. Well, we go ahead and combine, and just as we have seen the last two problems, the outside and inside terms are going to end up canceling because they're the same number but opposite in sign. And when we do that, we're left with our difference of squares. See, 81 is a perfect square, and negative x squared, or x squared is a perfect square. X to the third times x to the third makes x to the sixth. And well, the one minus sign in between means that it's a difference. Well, one more problem here. We've got a shape here, and if I break this into two different shapes, you'll see that we can do two multiplication problems and then add to come up with this area. This is called dissecting. Dissecting is breaking it into easier shapes. So here we have an area that is going to be x plus 5 times by x plus 5. So we've got to figure out what this is, but then we've also got this other shape here, so we're going to add on x minus 1 times by x plus 1. So it's kind of convenient. We've got a difference and a sum to multiply, and we have a binomial square. So let's see if we remember the rule. See, x and x make x squared, and we have x times 5 makes 5x. Well, remember the rule was that the inner terms are going to be exactly the same. So if you double that outer term or double the inner term, you'll get your answer there. 5 times 5, the last terms make 25. So we'll go ahead and add that together. We got x squared plus 10x plus 25. So the first term, square that. Second term, square that. And then take the product of the two terms and double it. It gives you your answer. Well, we're going to add on our difference in sum. So x times x makes x squared. X times 1 makes x, or 1x. And then negative 1 times x makes a negative x. Negative 1 and 1 make negative 1. So notice, same sort of thing as before. We cancel out those outside and inside terms when we have a difference in a sum. So what's left over? Well, we just have that x squared and that minus 1. So I'm going to take these terms and collect them. So I've got an x squared here and another x squared, and they're going to add together. And that's going to give me 2x squared. Well, do I have another x? No, I don't. So I can bring down that plus 10x. And let's collect these two terms here. 25, negative 1 makes a positive 24. And there's our answer. Now, we don't know what the units are, but we know it's an area problem, so let's go ahead and write down units squared. Get in that habit. So you've got an answer that makes sense. All right, well, that's the first half. The next half is handout number 5. We'll go over two examples on that.